Okay, today is 28th of March 2025. Today the chapter 3, transport layer is the topic. Transport layer, let's go one by one. What is the problem of using packet switching? Delay, loss, and out of order. What is solution? Put sequence number, acknowledge number, and timer timeout. And for timer timeout, we can check round trip time, which is called RTT. Usually average 10 milliseconds, maybe plus alpha. So basically, you can calculate sample RTT by when it is received minus when you send. Then you can calculate some value, which is sample RTT1, and also it is same as estimated RTT1. Based on that, we can separately calculate sample RTT2. Then based on that, we can calculate estimate RTT2 using exponential moving, which is 1 minus alpha sample RTT1 plus alpha sample RTT2. So this is the basic concept of timer timeout, and we'll see how sequence and acknowledge number really works. If you see here, you can check the start. So sender sends something. Sender can wait for maybe RTT, some timeout. But before that, if you sent 4 packets, and if you just miss second packet, then receiver will send same acknowledge number 3 times. Based on that, we can also know something's wrong. Then before RTT or some timeout, before the timeout, sender can just send 150 again. This is fast retransmission. And this is very conceptual thing to explain the concept. What is happening? Transport layer is layer 4, and network is 3, link is 2, which is put MAC address here. For more things, when we actually start the net connection, this is TCP. TCP, there is sync bit header. We make it as 1, and we also make sequence 1. Then receiver will send ACK number, which is sequence number plus data. So it will be 2, and also send ACK number and sync bit 1 for start communication. When they end the communication, there's also some rules. And so what I told here is basically we can check whether there is some congestion or error in network layer, which is by receiving duplicate acknowledge or timeout. Timeout is more severe problem because you are not sending anything. So we can split the situation 2, which is send base is what we will send the next time. So if we get acknowledgement 150, let's say here, then our send base was 100, but we can update to 100 because what receiver is saying is we receive until 149. So we can update the send base, and we can send from 150. Then if it successfully goes and data size is 50, then receiver will send acknowledge 200, which is they accepted from 150 to 199. But if not, they just receive duplicate, which then our send base will be same. So because our send base is same, we'll do fast retransmission, we'll just send again. And for TCP, so what we saw was kind of solving the error. We can split it as network congestion and flow congestion control and flow control. Flow control is regarding to not fill the buffer because they have router, and if sender or receiver's router becomes full, then it's not meaningful. So we should control the flow, and congestion is about inside of network. What we saw like fast transmission, these things are related things. And how they work is if it goes successfully, then they increase by 1 MSS by every RTT. But if they met some error such as receive 3 same acknowledgement, then they drop things to half, and they increase again, and they drop things half. This is how basically the congestion works. And if you see, this is one that I'm confusing part. So this is congested window. This is last byte we acknowledge, and this is not yet acknowledged, and this is we are ready to send. This size is window size, and we will increase. What we are increasing is this one. We will increase and we will decrease this window size. And for the flow control, okay, in CWND, the maximum size that we can have is defined by last byte we acknowledged x minus last byte we acknowledged is smaller than congested window size. So what we can get is last byte sent is x byte. Then what we can get is last byte we can send. Last byte we sent. This is I think I have an error on this part. I will explain it again. So thing is like this is what we acknowledge, and this is not yet acknowledged, and this is what we can send. So based on this, we can choose the slide window size. So TCP congestion controller, 3 things important is if there's duplicate acknowledgement, they drop the things down, and if there's nothing special, if it goes successful, they go increase 1 MSS by RTT. And also fast recovery can be one of the property. And another thing I didn't understand is when 2 TCP connections send things and they will meet at one router, so they are doing some kind of synchronizing the bandwidth, but I didn't understand how it really works. But I just remember they are doing some synchronizing things. Thank you very much.